Hello everyone, welcome to our channel. Today we'll solve numerical problem related to energy and momentum. The given question is, a uniform flow of 12 meter cube per second occur in a long rectangular channel of 5 meter width and depth of flow 1.5 meter. A flat hump is to be built at a certain section, assuming a loss of head equal to upstream velocity head. Compute the minimum height of the hump to provide the critical flow. From the given question, the figure form will be like this. This is the base level, and from here the flow occurs in this way, where here is the hump and this one is the y1 at point and this one is the point 2 at hump where critical height occur. So let's start solving this. So at point 1 discharge Q equals 12 meter cube per second. So from the given discharge we'll calculate the velocity at 1 equals 12 by 5 times of 1.5, where solving this the velocity v1 is 1.6 meter per second. And similar, the Froude number at point 1 will be p1 by root over g y1 whole root. Placing the value of all this, 1.6 is divided by 1.4, which is less than 1. When the calculated Froude number is less than 1, in such condition the flow will be subcritical. So in this case the transition will cause a drop of so we'll calculate. So now we'll calculate E1 using the formula E1 equals 1 plus V1 square by 2g. On placing the value, the Y1 is 1.5 plus V1 is calculated at 1.6 whole square is divided by 2 times of 9.81. On solving this, the result will be 1.63 meter. Now at point 2, that is at this point, critical depth yc equals q square is divided by g times of 1 by 3 equals, this can be written as q square is divided by b square g whole power 1 by 3. On placing the value, and on solving this the result will be 0.84 meter, where E2 equals AC equals 1.5 of YC, that is 1.5 times of YC is 0.84 equals 1.26 meter. Now using HL and placing the value of E1 is 1.63 equals the value of E2 is 1.26. The head loss HL is given by P1 square is divided 2G, or this equation can also be written as del z equals minus 1.6 whole square is divided by 2 times of 9.81 minus 1.26 plus 1.63, and on solving this the value of del z equals 0.24 meter, which is the height of the hump. That is y1 is equals to 1.5, yc equals 0.84, and this is del z. This side is del z, this side is yc, and the value of del z is 0.24 meter, which is the final answer. So for this time we end up the video up to this much. We'll come again with one new video. Till then, keep on watching our channel and don't forget to subscribe us. And if you have any concern related to water related subject, you can comment us in our comment section. Thank you.